So this is a recording which shows you how to balance redox reaction in acidic environment, and this is a little bit of a particular case, but about the compounds. We have a compound called the dichromate ion, and has a color which is yellow orange. Under acidic condition, like the ones you saw before, the dichromate ion can become chromium ion, Cr3+, and that's green. So when you do these kind of reactions between the dichromate and the chromium, the dichromate and some other agent, you will experience when the reaction is finished that the yellow-orange color of the solution has turned into green. So that's the sign of what happened. So the reaction will be dichromate and in this case we use the iron like you have seen before. Iron 2 ion becomes chromium ion and iron 3 ion. And that will happen in acidic environment. Now, as we have spoken this morning about how to do these things, the first thing to do will be sorry. The first thing to do will be to identify the two atoms participating to the redox. Well, if you see the chrome, I have to call the chrome ion. The chrome goes from being bonded to 7 oxygen molecules to be a single ion with 3 positive charges. So the first participant will be, of course, the chromium. And the second will be, of course, the iron, because it goes from +2 to +3. These are the two atoms, really, which are participating in this reaction. Then we have to calculate the oxidation numbers. We start with chromium. Yeah, its name is chromium. Then I hold on to that. The chromium is in a molecule called Cr2O7 2-. So to calculate the oxidation states of the chromium ion, I have to consider that the sum of the oxidation states must be equal to -2. I have 7 oxygen atoms, and each one of them has an oxidation state of -2. There's 7 of them, so it all counts like -14. And the chromium is the one I don't know. So there are 2 of them, then I call them 2x. Well, this equation solves by saying X is equal to plus 6. So the chromium goes from an oxidation state of plus 6, to, well, it goes to being Cr3 plus, so it has an oxidation state of plus 3. That's right. If that's right, so it means it has been reducted. It has gained 3 electrons. Now, I have to keep in mind that I have to count all the electrons which are moving in this reaction. Count all electrons. So there are 2 chromium atoms here and only 1 chromium atom here. So if one electron gains 3, if one chromium gains 3 electrons, 2 chromium atoms which are involved in the reaction will gain 6 electrons. Because I have to count all the electrons. Already at this point, this means that I have to take this in consideration. And I do that by multiplying the chromium by 2. Because I have to remember that 6 electrons were moving. So if one chromium gains 3 electrons, I have to find him on the other side. And besides, I have 2 chromium atoms here, and it has to be 2 chromium atoms on the other side. So that's the first change I have to do. The iron, as we saw before, goes from plus 2 to plus 3, meaning has been oxidated. It has lost 1 electron. So if 6 electrons are gained by the chromium and the iron only loses 1, it takes 6 iron atoms to satisfy the chromium. So to balance my equation, balance the electrons, I have to put a 6 before each time I see the iron. So our equation will become like this. I have to put 6 before the iron, I had put 2 before the chromium, and I put 6 before the iron. Now, the next step I told you we have to look after. It is to balancing the charges. So I have 2 negative charges here. I have 6 times 2 positive charges here. That means plus 12. Then on the other side of the arrow, I have 2 times 3 positive charges. That gives me 6 positive charges and 6 times 2 positive charges. That means 12 positive charges. So in all, I keep it in the same page, minus 2 plus 12 gives me plus 10. On the other side of the arrow, plus 6. Oh, sorry, it was 3 plus on the other side. I'm sorry. So that's plus 18, because 6 times 3 plus gives me plus 18. So plus 6 plus 18 will give me plus 24. So I have a difference of 14 positive charges lacking on the left. At the left side. So we remember that we were in an acidic environment. That means we have to add 14H plus where they are missing. So it means we have to add 1418 plus on the left side. And now we can put the rest of the equation here. So the next step was balancing the H and the O. That means now I have 14H and 7O, 14 hydrogen and 7 oxygen at the left of the arrow and none at the right. So I need to write 7 water molecule at the right side of the arrow. So we pick up our equation. And we write 7H2O. And that's how it is balanced in acidic environment.